Welcome back to AIX Beyond the Prompt. Today, I'm joined by Eric Elliott, Webby-nominated software engineering expert, creator of SudoLang, AI engineering leader, and one of our early pioneers of AI-driven development. As AI becomes a bigger part of how software is built, many companies are asking a difficult question. How should we evaluate engineers when coding is increasingly assisted by AI? Are traditional interviews still relevant? What skills matter now? And what separates great engineers from people who are just simply good at prompting? Let's dive in. Hey, Eric. Welcome.
Hi, it's nice to be here.
Pleasure to have you here. How was your day so far?
Pretty good. Doing a lot
Awesome.
of. I'm starting a new community and on PageSpace, and I'm having a lot of fun with that.
That's awesome. I heard about PageSpace. It will. I actually would like to hear more about it at one point. Without further ado, I would like to dive into this question we set out today, and I will ask you one big one here. So, Eric, if you were building an engineering interview process from scratch today, assuming AI tools are available to everyone, what would it look like?
Okay, so I don't have to think very hard about this because I've actually done that at scale at Adobe. We
Sure.
grew my team. I was engineering manager at Adobe, and we were very much interested in AI-driven development and using AI tools to help us with software engineering. So I actually ran this process at scale, hiring 30 plus engineers in the span of a few months. So one of the first things that I looked at was, they still have to have the ability to answer technical questions and have an idea of how system architecture works and all that stuff. So all those, architecture rounds and stuff like that, interview rounds, we do multiple interview rounds, right? So usually before we hire somebody, they talk to like 4 or 5 different people at least. Right. And so they'll talk to their hiring manager. I was head of Firefly. So I had managers that reported to me, and they would talk to their engineering manager, and they would talk to me. They would talk to other team members. I conducted the AI parts of the interview because I have the most experience on the team. And just for reference, I've been doing prompt engineering since 2020, since GPT-3 dropped in 2020.
That's a good 6 year already.
I'm the inventor of SudoLang, which is the most popular pseudocode programming language for AI models. So I've got a lot of experience with AI-driven development and the surrounding stuff.
So basically, before they got to you, they already probably vetted of the basics.
Yeah, well, not before they got to me because we were specifically hiring people who understood how to code with AI, right? And we also wanted to hire people who understood functional programming and modularity because that makes coding with AI a lot easier. So my interview round was a combination of functional programming and AI engineering basics. So, and when I say basics, I would ask them questions like, what does sparse attention mean? And why is it a good thing to limit how many tokens are in the context window at any given time?
Right.
So then hopefully they could explain to me the mechanics of the attention mechanism briefly. They don't have to be experts, deep experts, but they have to understand that, overloading the context window with too much content hurts the attention of the AI model and makes them perform worse, right? So that's the key concept I'm looking for with that question. Another thing that I'm looking for is do they know how to prompt? Can they design a prompt that actually works right there in the session? And for that, we actually pulled up an AI tool, and I watched them prompt the AI, and we tested to see if it worked. And we compared against a baseline that was already implemented, and we would compare the outputs. Which output was better and why? And how could it be improved? And we just discussed like what went wrong in the output, and what do you think you could change to make it go better? And the question that I like to use for that is write a prompt that you could append to any other prompt to make the model think better. All right.
Awesome.
And I actually have a prompt that does that really, really well. It's called reflective thought composition. And that's the baseline, but it's a really unfair comparison because RTC is the best thinking prompt I've ever seen. And it outperforms most of the thinking model AI. So it can make a non-thinking AI outperform a thinking AI just by appending this prompt. So it's not really a fair comparison.
That's actually really useful. Yeah. I love that. This actually could be useful in real practical ways. So far I'm hearing two things from you. One is like a workflow efficiency, like using the minimum effective dose of tokens, and the prompt quality, right?
Mm-hmm.
And then that is actually but these what we was using for years, the coding challenges, algorithm interviews, is this still measure anything valuable?
Coding challenges where they're actually asked to develop source code by hand from scratch without using AI, not valuable at all whatsoever. No. And the reason for that is because on my teams, we pretty much 100% of our code is AI generated, close to 100%. We still read it, we review it. We're all fluent in code, we understand code, but I don't care if you know how to write it from scratch anymore.
Totally.
And the reason that I don't care is because I met this guy, his name is Jono, and he developed PageSpace from, he was a vibe coder. He learned by vibe coding, and he developed this PageSpace over the span of a year, and he never learned how to code. He doesn't, to this day, he couldn't code these features from scratch if you asked him to.
He still created something valuable, and
he created
even by you something which actually
he created my
even
favorite.
in your eyes, it's actually something valuable and useful.
It's not just valuable; it's my favorite productivity software I've ever used.
That's a great thing to hear.
By a huge margin. And when I a lot of vibe coders, they have no idea about security, and they just don't implement security whatsoever. It's just not there, right?
Yeah.
But Jono took the time to really dig in. He had the AI teach him about security. And the funny thing is, AI really sucks at implementing security. They'll just leave the doors wide open by default, right? And they won't even implement security measures like rate limiting and stuff like that on authentication endpoints. And they just leave the doors wide open. They'll even include like full-on admin keys in the client-side code, hard-coded, and publish them to GitHub where they will leak, right?
Sure.
So
you call it so this gentleman name is Jano, right?
Mm-hmm.
So he actually generated thousands of lines of code with AI, right?
Yeah,
but he actually made sure
70,000.
that this is but here we're coming to another point which I'm very excited to actually hear about it, and maybe through Jano and then your explanation we can understand better. So someone can generate thousands of line code with AI today, right?
Mm-hmm.
But what separates a great software engineer from a great prompt engineer? Can we even make the distinction today, or how can we talk about this?
So a great software engineer is somebody who is able to produce great software. So if you're using prompting to create good software, you're a software engineer, right? If you're a good prompt engineer, prompt engineering can be applied to anything, like generating images or videos or anything, really. So the only real distinction is, what are you using those prompts for? If you're using it to make software, you're a software engineer.
Okay, that makes sense.
All right. That said, part of being a software engineer entails understanding the engineering process. And that engineering process, even for humans, is you assume that there will be mistakes, there will be bugs, and your job is to protect the code base, the production code base, against those bugs. So your main job is the quality checks and balances that are going to make a big difference. You know what I mean?
Yes. So what other skills would you actually put next to these quality check, like architecture, product thinking, communication, debugging? Like what are actually those skills that, as you know, AI is writing the code, which skills are more valuable rather than less from these?
All of those skills, but debugging is probably not as valuable anymore, because if you just give an AI agent a bug report, it's usually pretty good at finding the bug much faster than any human that I've ever seen. Right? Better than me at finding bugs usually. If I know the bug is there already and I point out the behavior and what the expected behavior should be, the AI can usually find the bug or replace the code and make the bug disappear just by replacing the code. And AI can rewrite code so quickly that, just deleting the whole module and replacing it with a new one sometimes just works, right? As long as you have a good automated test suite. And this is another major point that I bring up with in those interviews. So I'm asking about functional programming and modularity because it's really important. AI has a tendency to just glob everything together in one gigantic monolith, but that's not a very effective way to write software. A much better way to write software is to break things apart into independent modules where a change in one module doesn't break another module, right?
Yeah.
So modularity is super important.
The basis of React and all of these things which compartmentalizing the software, Yeah,
modularity and separation of concerns is very important. So I emphasize that in the interviews, and I like to see if the interviewee understands what separation of concerns means. And that means really you want to put things into 3 different buckets, right? Those buckets are effects, which are things like network requests and I/O and stuff like that, right? The things that affect the state outside of the immediate function, right? Effects. And then there's pure logic, which is just computation. So any transformation, like adding two numbers, is pure computation, or doing a logical predicate. So if this, then that, right? That's pure logic, right? And then we have the display or the user interface.
Yes.
And I like to separate the user interface from effects because you don't want to tie the user interface directly to the network I/O and the persistent layer, right? Yeah. So there's this persistence layer that like changes the state of the outside world. There's the UI layer that shows the user the state, right? And then there's the transformation, the pure logic, the transformation layer that does all the calculation and thinking, right? So you got the brain, you got the actions, and you've got the UI.
Yes, I have to be honest to you. This is just one more than the usual thing I ever heard. That like usually what I was told that separate the UI from the logic, and then I'm pleased to learn about the way how you thinking to actually add one more extra layer for the effects.
Yeah,
and for the API calls and for sure. Yeah. I can see the point, and I can also see the point of people who there were engineers who actually were not bothered by the fact that see everything in one blob. They say, like, at least I don't need to go through 10,000 files to find everything. Everything is right here. But then I also understand that the basis of the compartmentalization and the modular nature of the software development.
Yeah, so that They call them beautiful monoliths. The problem with beautiful monoliths is that you can't automate the testing of beautiful monoliths because they're too tightly coupled to everything else. If you want to test them with automated tests, you have to mock everything out. And then if you're mocking everything, you're not testing the whole system. You know what I mean? So I actually have a chapter in my book, Composing Software, called Mocking is a Code Smell, that goes into detail about this, pretty deep detail. But basically it says, like, you really want to test the pure logic as independently of everything else. And that's really easy to test. And you want to separate that out, because that pure logic is where all the decisions and all the thinking and all the stuff that matters really happens in that pure logic. And if you get that pure logic right, chances are really good that your application is going to work correctly. So that's the easiest part to test. Isolate that from everything else. All right.
Gotcha.
And,
yeah, that's,
and when you
makes
do
sense.
that, it also protects your code base against hallucinations and errors caused by the AI, because it's going to see, oh, I made this change and now my test is failing. I have to fix this. Right. Mm-hmm. So automated tests, and this is the other part that's really, really important, is automated tests. So I do everything with TDD, test-driven development, right? So you write a test first, then you write the implementation, right? And then you can refactor with confidence, knowing that if you make a breaking change, your tests are going to catch it, right?
Can you just say very quickly about the setup of this test-driven development for the listeners and they understand as well?
Sure. So I do test-driven development on the pure logic as much as possible. And the way that works is we write a test against the pure logic, and we have a framework called Rightway. And Rightway is specifically designed to work well with AI. Actually, it was extracted from a web app that we built for one of my companies a long time ago in 2017, before AI-driven development was a thing. But we adapted it to AI because it uses a lot fewer tokens than things like Jest and stuff like that, right? So it's an assertion API that forces you to follow the Rightway principles. So Rightway is also an acronym that stands for readable, isolated and integrated, thorough, right? And E is the brain.
It doesn't matter.
Brain died.
It doesn't matter. But
brain died. Explicit, right? So you want to make sure that you've got the isolated and integrated part is important, because you've got two different kinds of tests and you need them both. You have your unit tests, which test code in isolation, right? And unit tests should be testing your pure logic. But then you need integration tests. Remember when I said mocking is a code smell? It's because if you mock everything out, you're not testing the system end to end. So integration tests test the system end to end and make sure that your modules work well together, right? Unit tests make sure that your modules work well, isolated from the rest of the app on their own, right? Integration tests and end-to-end tests, functional tests, make sure that your modules all work when they're integrated together in the context of your application. And we'll use tools like Playwright for that, and actually exercise the real UI and hit the real databases and stuff like that.
So you're getting actually human-like behavior, to see.
Exactly. They might be test databases with test data, but you're hitting the real databases in a production-like environment with end-to-end tests. Right, or functional tests.
Perfect.
Yeah,
sounds good. I really wanna jump into just a slightly different subject, also related to the original AI interview question. This is what I call the junior engineer problem. So I wanna pick your brain about this idea. So a lot of people, especially people who are getting out of universities, worry that AI is removing the learning path for junior engineers. So how does someone become senior if AI does all the beginner work? So if you cannot be senior through practicing because AI does it for you, how do you become one?
I think Jono is a perfect example of this. This was a one-man show who built the best productivity app I've ever seen. Over the course of a year, starting from zero, he knew almost nothing about software. and software engineering, and he still managed to learn enough to build a very good application, right?
Okay.
So the idea that AI is going to make juniors disappear, it's ridiculous. It's not true. It can, it can do that on an individual basis if you lean too much on the AI and you just expect it to do your homework for you, right? But the real engineers, the real people that are really all about problem solving and learning and getting things done, they're using the AI as a brilliant tutor who is always available to answer their questions, and they're learning a lot faster using AI. So AI is helping them on ramp, because if you've got like a senior level engineer available 24/7, you can just tap and say, hey, explain this concept to me in depth, right? And then quiz me on it, have me implement it, you know what I mean? Stuff like that. Then it really sharpens your learning and accelerates it. It puts you on this fast path to accelerated learning. In fact, it's done that so much that around 2023, I noticed, like, I used to have a ericelliottjs.com website, right? And I just shut it down like a couple of months ago, or a couple of weeks ago, and now I'm replacing it with a community of AI-driven developers, right? People stopped subscribing to it. People stopped around 2023, stopped getting traffic, because why pay for a service that is less available and less directly answering your specific questions when you can just go to ChatGPT and ask the question that you need answered, and ask something that is basically a senior level engineer to explain a concept to you.
This is the reference for the juniors. Yes.
Yeah.
There's a help. So basically, Jano went from 0 to 60 in a very short time.
Yeah.
So in a way, could we say that he jumped through the junior path? He jumped into a great level.
I would pay him at the rate of a senior engineer, and he's only been doing it for a year and a half.
That's great.
Yeah.
That's actually very encouraging for people out there. If you have the ambition and if you have the desire and the passion to create something great, then you can do it, even without climbing the ladder slowly.
He didn't go to school for this. Right? He just figured it out.
I always love a good story. So that's great. Now, give me something that AI cannot replace. Like, what is one thing that AI still can do as exceptional as a good engineer would do every day? If anything comes to your mind.
AI is nowhere near the level of the top experts in the world at their jobs still, right? So, for example, I started building neural networks in I launched my first one in 1998, right? And I've been, I'm a Webby-nominated AI engineer. Worked on Stanford Research Institute spinoff as a tech lead. We powered the Wall Street Journal World Stream, which used natural language understanding for video in 2012, right? So I've been around the block and been in AI, deep in AI for a long time. And when I try to work on things like I've got a new kind of model architecture, a novel model architecture that's never been done before. The AI needs a lot of hand-holding to figure out how to implement it correctly, right? It needs a lot of hand-holding. It tends to gloss over, do a lot of hand-wavy stuff, and kind of half-implement things and not actually dig into the details and do it right until I specifically spell out, here are the exact requirements, here's the exact algorithm you need to implement, et cetera, right? It's not even close to on my level in terms of like novel research and development for AI architecture. Also, not even close to on my level at security.
The implementation of security features out of the box. Gotcha.
Yeah, it's really, really good at, if I tell it adversarially, attack this thing and figure out how to break it. It's really good at figuring out what the attack surface is and stuff like that. But then it will completely miss the fact that, it has a tendency to lean into what everybody does and think that's okay. So for example, if you tell it to security review a password flow, it'll make sure that it's using a work algorithm like bcrypt or PDKDF2 or something like that, right? But completely miss the fact that passwords themselves are obsolete and unsafe and should not be implemented at all. You should be using passkeys instead.
How about some passkeys, right? Yeah.
Yeah, exactly. So in terms of like security and stuff like that, it's nowhere near my level, right?
Maybe because it's still very literal, because you was not asking it to give you the best security way. You asked him to take a look if my password flow is okay.
No, so that's not what I'm asking, right? So when we do the security reviews, or when I would prompt an AI, I wouldn't say, take a look and see if my password flow is okay. I would say, look for security issues with this thing, right? And dig in and find the best practices and look for security issues here. So it digs in and finds the best passwords, the best practices for password authentication, instead of realizing password authentication itself is not a best practice. You know what I mean? So it's missing the forest for the trees. You know, it's not seeing the big picture.
For sure. I am probably people. So the people who's actually watching this talk, and many of them are engineers. If you are a software engineer watching this and feeling uncertain about AI, what would you focus on learning over the next 12 months? Things changing fast. So 12 months is the long period. So what would you learn the next 12 months which would actually be still relevant, or actually useful in this AI-driven development world?
Agent skills, especially pairing agent skills with traditional symbolic code. And by the way, I find myself having to define symbolic code because people have not had the contrast. But like the code that you used to do, that's symbolic code, right? The code that you used to implement using logic and predicates and loops and stuff, that's symbolic, right? Symbolic logic. And so combine your AI stuff, your AI skills, the prompts and stuff, with symbolic checks and balances. Things like linters and unit test runners and playwright and all that stuff. But also static analysis tools that go into things like cyclomatic complexity and information theory to determine you can use some information theory. So for example, there's a skill in the AIDD framework, which is a framework that we built to help with AI-driven development. There's a churn skill that checks to see if there's too much duplication in the code. And it does that using information theory. It compresses the file and then compares the compression ratio. It looks at the compression ratio. If it compresses too much, that means there's too much duplication in there. It's too much self-similarity. So it doesn't look
at the code itself, but it's actually detecting the duplicated parts.
Yeah, it's looking at the information. So we use compression as a proxy for code duplication or too much self-similarity.
Yeah, okay, that's good. So this would be the areas where you would focus on.
The checks and balances is everything, right? If you want to keep a fleet of AI agents on track, then you got to build the checks and balances that keep them on track.
Give us some details. Give us some actual concrete detail, like at least one, when you say checks and balances.
Okay, so the best way to make sure that the AI is producing code that is actually meeting the requirements is to have a really good understanding of what those requirements are, and that understanding should be testable. So, and it should be testable in a way that you can see this passed or this failed, right? And even if that you're doing AI prompts and it's not giving you deterministic answers, right? Deterministic answers are super easy to unit test because you can just say, I take this input and I expect this exact output. But with an LLM response, you can't do that. You have to figure out, does this meet this requirement rubric? and you have to use something intelligent to judge its output. So what you can do is you can set up an adversarial cohort of judges that are looking at different aspects. Like I have one that reviews writing to make sure that it's writing like a human and not inserting a bazillion M dashes and using a bunch of AI has a tendency to use a whole bunch of contrastive emphasis, like overuse of contrastive emphasis, and like do a bunch of stupid things that just scream, this was written by AI, and it's fluff, right? So you can actually have an LLM judge and look at it and say, oh yes, this is information dense versus this doesn't have a lot of great information, and it's mostly fluff, right?
Okay, I like the LLM judge name.
Yeah,
because that's a good name for it.
Yeah.
And then you would like build it for yourself for your own purposes.
So
and then
we have a framework that, remember when I told you about RightWay, right? The unit testing framework, right?
Yes, definitely.
So RightWay AI is a framework that's bundled with RightWay that tests LLM responses, and it actually will kick off judge agents, and those judge agents will assign a pass and fail and also a numerical score. So you can judge that, you can see how well, not just did it answer the question adequately enough to pass, but also did it give a great answer or kind of a meh answer. You know what I mean? So we've got quantified qualitative evals, and that's an important aspect of making sure that your prompts are on point and the prompts are going to perform.
So those are already built in the right way.
Yeah, you can download RightWay and use it, install it from NPM, and just start using it in your projects right now.
Right?
It's open source, yep. And
awesome.
It works for any programming language. So your project can be in Python, and as long as you can still install from NPM, right? You can still install it. You can still run.
Then it will work on it.
Yeah,
it will be applicable.
Yeah. Because what you're writing the tests not in Python or JavaScript or anything like that. You're writing the tests in SudoLang, which is the language that I designed that is designed to run on top of LLMs, right? So, and your tests don't have to be in the same language as your code. So you can use this no matter what language your application is written in, and judge your AI prompts as long as your AI prompts are in isolated files and you can import those prompts and then feed those prompts to the AI, to the language model, you're in good shape.
Awesome. All right, Elliot. I have one final question to you. And let's give something to talk about it to people. What is one belief about AI and software engineering that you think people most are getting wrong right now? What is one belief that the people getting wrong this time around? Something that it's almost like a cliche, or like it become a fetish of AI or something. Like, what is it like? What would you bring up if anything comes to your mind?
So a lot of people see AI fail at something or just do a bad job at something, and then just assume that it's always going to be bad at it, right? Without trying to prompt it to make it better, right? And I think that's the biggest mistake that a lot of people are making, is they're underestimating the AI. This is like throwing somebody who's never played the piano in front of a piano and expecting them to play Mozart right out of the gate, right? They're not going to do that. But the big difference is you can create an agent skill or download an agent skill, just plug it in, right? And suddenly it can play Mozart. Right? This is the major advantage of AI, is they can just download skills, right? And you are probably underestimating the capabilities of your AI.
I probably do. I myself, for sure. And it's always a pleasure talking to you, because I remember the very first time I did talk to you, it struck me how artfully you are using the AI to create software. And then I was really excited to talk to you. So yes, I am really appreciate that you joined us today, and then let's do another session when we can go deeper into one of these subjects. And I actually want to hear more about about your work with the page space, and then even even things like SudoLang. I guess not many people are going to know about it, and then they would love to.
Yeah. I'd be happy to. Thanks for having me.
Sounds good. Thank you, Eric.